Now the topic before us is types of databases. Now we will discuss what are the various types of databases. We will also understand these types of databases with the help of real life examples. That is, what are those, which are those organizations, or what are those fields in which this particular type of specific database is being used. We will also understand whether one type of database is used by a one organization, it is sufficient, or whether the organization may have to use a combination of different types of databases. We will discuss all it in now. First we will discuss types of databases. There are various types of databases. Each type of database is suitable to specific use cases and requirements. Now, these are the common database types, that is relational databases, no SQL databases, object-oriented databases, graph databases, time series databases, new SQL databases, and in-memory databases. These are some common databases types. Now, first we will discuss relational databases. Relational databases organize data in structured manner using tables, rows, and columns. That is, if we say that this is the table, these will be the columns, and these will be the rows. If we say that this is the employee table, then it will be serial number, or first it will be employee ID, then employee name, address, then it will be salary per month, some other particular. This is the employee ID. These are the columns. These are the rows. So all the information which the organization may have to store, and it is using the relational database, the information is stored in the basis of these tables. The company may be selling different types of products, then product ID, its price, something like that will be mentioned in the tables. These type of databases follow a fixed schema, that is the fixed plan, where data types and relationships between tables are defined in advance. What is the data types? Data types means, in the case of employee ID, we can only add say 1, 2, 3, 4, 5, or the employee ID may be 5, 6, 3, 1. We here cannot add ABC. This is the data type. When we are writing about name, we will use the name, say Ila, Rahil. Here in the case of name, we cannot write 1, 2, 3, 2, 3, 4, because these are not names. So there is the fixed data type which can be added or mentioned in the particular column, in the particular field. Here we can add only particular type of data. In the case of salary, we cannot write ABC. We will have to mention $1 to $3 or $5, $6, $7. So these are the data types, and we can add only the data type which is suitable to the particular column. So there is further, it is written that there is a relationship between tables. How the relationship is established? We take another example. Suppose there is an organization which sells various types of products. We may take the example of Amazon. These are, here it is the customer table. Here it will be customer ID, then it will be followed by customer name, address, then email address. Then there is order ID, order table. Here the information will be stored in the form of, say, order ID, then order date, products ordered, then here it will be the customer ID. So these two tables are related with the one ID, that is customer ID. This is the primary key in the first table, and it is the becomes the secondary key, foreign key in the another table. Here it is foreign key, customer ID is here foreign key, here it is primary key. So the relation between the customer table and the order table has been established with the help of keys, that is the primary key and foreign key. Structured query language is most commonly used to interact with the database. Structured query language makes it easy to search, add, update, and remove data in relational database system. This type of database is commonly used in e-commerce platforms, financial services. Financial services means banks or non-banking companies, NBFC companies, where data consistency and well-defined relationships are crucial. Examples of relational database are MySQL, PostgreSQL, Oracle, Microsoft SQL Server. Now we make the mention of real life example of use of database, relational database. Relational databases are extensively used in banks so that they can organize and manage their financial data. The databases of the banks contain various types of tables. That is, the relational databases of the banks contain various types of tables, such as the customer table, where they contain the information in respect of their customers, such as their name, what is their address, what is their contact details, etc. Then their relational databases also contain accounts table, that is, what are the different types of accounts which are held by the customers. Relational database of the banks also have or manage transaction table, that is, what amount has been deposited by which customer, what amount has been withdrawn by which customer, what amount has been transferred by which customer. All these transactions have to be recorded in the transactions table. Then there are card tables, that is the debit card or credit card details, etc. The relationship between these tables is established using primary key and foreign key. As already discussed, suppose the bank may be having customer table in which it will be having customer details, and in the second there may be, say, transactions table. In the transactions table there may be transaction ID, transaction date, and there may be the customer details, customer ID. Or the relation may also be established with the help of accounts table, that is the what is the account number. On the basis of that, the relation is established between the customer table and transaction table, or customer table and accounts table. All this relationship between the tables is established with the help of keys, primary key, foreign key, or composite key. We will discuss about these keys in details later on. So all these tables which are there in the relational database of the banks are interrelated with each other with the help of keys. Now the next is NoSQL databases. While relational databases rely on predefined tables and relationships, NoSQL databases are more flexible. They store and manage data without a predetermined way of organizing the information. NoSQL databases are a good choice for storing and managing data in a variety of scenarios. These databases, that is the NoSQL databases, are flexible, scalable. Scalable means if the workload increases, the resources can be increased. These databases are flexible, scalable, and efficient, which makes them well suited for modern web applications, big data analytics, and scenarios where the data structure may change over time and require rapid scalability. That is, if the workload increases, data increases, the resources may be increased to tackle the workload. NoSQL databases are suitable for handling large scale and diverse data, including unstructured or semi-structured data such as documents, graphs, audio files, video files, social media posts, graphs, etc. Now the examples of NoSQL databases are MongoDB, Cassandra, Couchbase, Redis. Now we make the mention of real life example of use of NoSQL database. Social media platforms like Twitter, Instagram deal with vast amounts of user generated content. User generated content means the users of the Twitter and Instagram make many posts, they tweet, they post many images, videos, or comments on those platforms. All this data can be unstructured or semi-structured, which makes it difficult to store and manage in a traditional relational database. That is, all this type of data, whether it is audio files, video files, or other social media posts, all this type of data cannot be organized or stored with the help of relational database. Here the role of NoSQL database comes, which can effectively handle these types of unstructured or semi-structured data. NoSQL databases are ideal for storing and managing this diverse and evolving content. Now we discuss about object-oriented databases. Instead of using tables, rows, and columns like relational databases, object-oriented databases store objects directly along with their attributes and relationships. However, these databases, that is the object-oriented databases, are less common than relational databases and are often used in specialized domains. Specialized domains mean only in special fields like scientific simulations, computerized aid designing, or computerized aided manufacturing systems and multimedia applications. The examples of object-oriented databases are ObjectDB, and Versant. Object-oriented. Now we discuss about the real life example of use of object-oriented databases. Object-oriented databases can be used in content management system of websites. In the content management system, various types of content such as articles, images, videos are managed. Because on websites, the users upload various types of articles, images and videos. All these types of data has to be managed, and object-oriented database can effectively handle this type of data. Each content type, that is article, images, videos, can have different attributes and properties. That is, all this type of data has its own characteristics. For example, an article may have a title, content, author and publication date, while an image may have a file name, size and description. Object-oriented database is a good choice for content management system, as this database can store each type of content as a separate object with their attributes and relationships. Now, graph databases. Graph databases are designed to store and manage data in a graph-like structure. Graph databases represent data as a network of interconnected nodes, edges, and properties. Graph databases efficiently handle complex relationships and provide powerful querying capabilities. Querying capabilities means when you want to search anything, any type of data, and from the graph database will immediately provide you the relevant information. Now, the graph database are suitable for applications such as social networks, recommendation engines, fraud detection, and knowledge graphs. Recommendation engine means what? When you are making use of Amazon, you may search different types of products. Suppose you are searching the particular type of product, say jewelry. You are searching for the same for say 2-3 days, and after 3-4 days you will find that you will be receiving in your Facebook or in other social media platforms the recommendations related to the jewelry. How it happens? Because the companies or the websites make use of graph database. Services like Netflix and Amazon use graph databases. The graph database allows Netflix to track the connections between the users and the content they watch. This information can be used to recommend new content to the users as well as track their viewing habits. Now we will see another example of real life example of use of graph database. Amazon also uses graph database to store information about its products, customers and orders. The graph database allows Amazon to track the connections between the products and customers. This information can be used to recommend new products to the customers as well as to track their purchase history. The examples of graph databases are Neo4j and Amazon Neptune. Now the time series databases. Time series databases are specialized databases. These are designed to handle time-stamped or time series data where values change over time. Now, what is the meaning of time series data? The time series data is the data that is collected at regular intervals and has a timestamp associated with each data point. For example, we can understand the same. Say that if we are dealing with stock market, and in the case of stock markets, these time series databases are used. The time series database will store the data such as the price of a particular share of a particular company was such at that particular time. This is the time series data. That is the value of a particular share has been recorded, and the time of that recording of data has also been mentioned. What is the price of the particular share at particular time has been recorded, and this type of recording is done by the time series database, where the time is also recorded along with the data. To store data, time series databases often use compressing techniques to reduce the amount of disk space required. As the time series databases store data at regular intervals, the volume of data becomes enormous. So these type of databases use compressing techniques so that the amount of space required for storing that data is minimized to the extent possible. Now, what are the examples of time series databases? Examples of time series data are stock prices, exchange rates, that is the exchange rates of, that is the rate of the foreign currency also changes every minute. These trading volumes on the stock market also change every second. This type of data, that is the time series data, can be used to analyze market trends, identify trading opportunities, and manage risks. The new time series databases are designed which use cloud and artificial intelligence and machine learning technologies to store and analyze time series data. Now, the examples of time series databases are InfluxDB, Prometheus, OpenTSDB. Now, we here give the real life example of use of this time series database. The power plants are continuously generating a large amount of time series data or time stamped data. This data includes information about energy consumption patterns, that is, what is the consumption pattern at regular intervals, that is, whether the load energy is being used is at peak or the energy is being used at lower level, what is the power generation from various sources at different intervals of time, and what is the voltage levels at different intervals of time. All this type of data is generated by power plants. So the time series databases are employed to store and analyze this time stamped energy data efficiently. They help energy operators and analysts to monitor and optimize energy usage, identify peak demand periods, that is, what are those times during which the consumption of electricity is at peak, predict energy needs, and detect any unusual patterns in power generation or consumption. Now, the next databases are new SQL databases. This is the category of databases that aims to combine the benefits of traditional relational database management system and NoSQL databases. These databases are designed to scale horizontally. What is the meaning of horizontally or scaling vertically? Scaling horizontally means to increase the resources, that is to increase the number of machines so that they can so that the organization can deal with the output working deal with the higher workload. It is scaling horizontally. If we say that scaling vertically means to upgrade a particular machine or a particular server. These databases, new SQL databases, are designed to scale horizontally. That is, the number of machines can be increased to deal with the increasing workload or increasing data load. Like new NoSQL databases while maintaining ACID. ACID means these are the properties of relational database system. A stands for atomicity, C stands for consistency, I stands for isolation, D stands for durability. We will discuss all about this in detail in our subsequent courses. So these databases have the properties of scaling horizontally and also maintaining the ACID properties. The examples of new SQL databases are Cockroach DB and NeoDB. Scaling a database. What is the meaning of scaling a database? Scaling a database is the process of increasing the capacity of a database to handle more data or more users. There are two types of database scaling. One is horizontal scaling and the other is vertical scaling. In the case of vertical scaling, it means upgrading the hardware of a single machine or a single server, such as we can upgrade the amount of RAM, random access memory, CPU or storage space of a one particular server or one particular machine. Whereas in the case of horizontal scaling, it means adding more servers or more machines or nodes to the system so that the increased workload can be effectively handled with. Now, we give the example of real life example of use of new SQL databases. New SQL databases are used in e-commerce industry, where a large amount of data is generated daily, including product catalogs, customer information, orders, and inventory levels. These databases allow e-commerce companies to efficiently manage concurrent transactions. Concurrent means simultaneous transactions. Handle real-time inventory updates. Real-time inventory updates means when you are purchasing something, immediately, and when you purchase a particular product, suppose the website was showing it as 60 products were balanced, and when you purchase 2 items of that product, the inventory system will immediately reduce the inventory to, and the website will show that the products balance are 58. These databases allow handle real-time inventory updates and ensure that the customer's orders are processed reliably. If the real-time inventory update is not there, then it may be possible that you make the order, you make the payment, but if the inventory is not proper and in not real time, that is the latest update of inventory is not being shown on the website, then a large number of orders may come from the different customers, and when the products are not there, the company will not be able to deliver the same. It will result in a lot of customer dissatisfaction, because the companies will have to feel sorry and will also have to indulge in unnecessary task of refunding the amount to different customers. So new SQL databases provide such benefits, that is, allow manage concurrent transactions, handle real-time inventory updates, and ensure that the customers' orders are processed reliably. Now, next is in-memory databases. These databases store data directly in RAM, random access memory, which makes them much faster than traditional databases that store data on disk. That is, here all the data in such type of database, all this data is stored in RAM and not on disk. These databases provide high speed processing, data processing, low latency, and real time analytics, so that they are suitable for applications such as online gaming, e-commerce platforms. That is, these databases are used in online gaming and e-commerce platforms. Now the question will naturally rise, we are making mention of e-commerce platforms time and again, whether e-commerce platforms are using this particular type of database or the previous. In fact, the organizations such as the e-commerce platforms or social media platforms have to handle different types of data types. So the one type of database is not effective to handle or manage all different types of databases. So the organizations have to make use of different types of combinations of databases, so that they can provide efficient and better services to their customers, and so that the data is properly stored. Some of the well-known companies that use in-memory databases include Twitter, Facebook, Amazon, etc. The examples of in-memory databases are Redis, Apache, Ignite, Timestamp. Now, where they are used, these databases, they are used in financial trading platforms, because they provide lightning fast data processing and quick access to critical market information. The fast speed of these databases allows traders and analysts to execute trades rapidly and make timely decisions, giving them a competitive edge in the fast-paced financial markets. If you have any interest in the share market or stock market, you might have seen that when there is a news outbreak about a particular company reporting very good results, then when we see this on the television, we open our computer system and may start purchasing a particular stock. So the stockbrokers or the financial analysts make use of in-memory databases, so that they can execute the trades rapidly and make timely decisions, because these databases give them the capability to execute trades rapidly, so that they have the competitive edge as compared to the others. Now, the another question which we have also discussed somewhat earlier, whether a company sticks to one type of databases. The answer is no. A company does not typically means generally. A company generally does not stick to one type of databases. Different types of companies make use of different types of databases rather than sticking to one type of databases, because a company has to store the data or manage data not only in respect of their customer, but it also has to, say, Amazon or other social media platform may have to store or organize data in the form of, say, audio video files, social media posts, customers details, accounts details, other. So all these data types are different. So using a particular type of database, say relational database, may not be suitable to handle different data types or different types of data. Each type of database has its own strengths and its own weaknesses. A company may consider many factors while choosing a database, such as what is the nature of the data, what is the size of the data, what is the level of the performance they require, what are their scalability needs, whether they want to handle more workload in future, whether there is any whether we imagine that our workload will increase in future, in the near future. If we think so, then we will have to opt for that database which gives us the capabilities of scalability. Then the organization also looks into the cost consideration, which type of database is within the budget of the particular organization. What is the existing infrastructure? If the existing infrastructure is very out of date, the organization will naturally like to upgrade the same. What type of expertise is required? If the expertise is of very higher level, then naturally more skilled labor will be required to be hired for the same, and more budget will be required for the same. Then what are the industry specific requirements? All these types of points: budget, level of expertise, scalability, what is the type of data we want to store, all these types of considerations have to be taken into consideration while we are making a decision with regard to the use of particular type of database which have to be used by us in our organization. So there is no one size fits all. That is, we cannot say that one particular type of database is more than sufficient for any one particular organization. So any organization may have to use a combination of different types of relational databases on the basis of its requirements. Now we here give you an real life example of use of different types of databases by a particular organization. You might have heard the name of Airbnb. It is an American company. Many decades ago, the people were feeling a lot of problem when they were going for, say, on a tour to some foreign country or to some other place. They were finding it very difficult because the charges of the hotels were very exorbitant, and the customers or the people or the tourists were not able to afford the same. The company named Airbnb realized that there is a potential to cater to this type of customers who are coming for some short time at some distant place. This company created a new market, that is, they realized that there is a potential to tap this type of tourists or the customers. It created, say, a website, and it contacted the owners of the different or buildings who wanted to earn something, as they were having some portion in their house as vacant, and they were ready to give it on rent for some brief period. It collected the data of all these owners who were ready to give their accommodation for a temporary purpose to the tourists or other persons for a short period. Though at present Airbnb also is providing the facility of rental facility to customers, that is the long time stay. So this company allows the people to list their homes and other properties for rent to guests. It acts as a broker and charges a commission from each booking. Now, when the Airbnb at present, the Airbnb has a vast amount of data, lakhs of owners listed on its websites, which are spread in different parts of the world. If you want to visit any country, you can visit their site. We are not promoting their site. We are only just giving the reference of the use of databases by this organization. Airbnb has to deal with vast amount of data related to property listings. That is, a large or thousands or lakhs of properties are listed, where they are located, what is the rent. Then if a particular customer approaches Airbnb site, whether he has booked, if he has booked, which particular property he has booked, user profiles, that is the customers profiles, reviews and more, that is the reviews which are being put, that is the different types of data Airbnb has to deal with. It is not, doesn't mean that the other organizations have not to deal with that. We are only discussing about a particular example. By using combination of different databases, Airbnb handles different types of data, because the organization may have also to upload the pictures of different sites or different properties. Airbnb provides fast and relevant search results to the users and analyze user interactions to improve their platform. Because Airbnb uses the different types of databases, it is in a position to provide better customer service to the customers. Thanks for watching. If you like our course, please spare some time to give a star rating to our course.